Hi Year 11. So last lesson of the topic then. So this lesson is called Forces and Braking. And actually this is one of those lessons that is very real life for you because you'll be taking your driving tests in the next couple of years. And everything that's in today's lesson is not only relevant for your science curriculum, but in terms of knowing how to safely drive a car and how to stop a car. So today's lesson is, like I say, very real life. Let's start with our KIP quiz. So 1 to 5 on your mini whiteboards. You know what to do now. So pause the video and come back when you've got your 5 key terms. Okay, so number 1 then, the equation to calculate speed is speed equals distance divided by time. Number 2, typical running speed is 3 meters per second. Number 3, this equation, final velocity minus the initial velocity divided by time, is the equation for acceleration. Number 4, the difference between the stretched and unstretched lengths of a spring is extension. And then number 5, materials that are attracted by a magnet. And that we say then that they are magnetic. Okay, so on to our lesson then. So forces and braking is the title today. And today we want to be able to define the term stopping distance. We need to explain methods used to measure human reaction times. Okay, so we need to explain what those methods are and record typical results. So what would a typical reaction time be? Interpret measurements from simple methods to measure reaction time. So if I gave you some results, what would you say about them? Then we need to evaluate the effect of various factors on thinking distance. That will make sense once we look at them. Explain factors that affect the stopping distance during an emergency stop of a car. So if something's just come out in front of a car, how many meters will it take you to stop? And then explain the dangers caused by large decelerations. So let's look at that now then. So why do you need to stop a car? See how I'm saying this is very real life today. It could be that something's run out on the road in front of you. So if you're driving along, this maybe looks like Australia based on the kind of on the terrain. But here we've got a car coming along and then there's a deer walking out in front of the car, so you need to put your brakes on. Could be that the traffic light has gone red and you need to suddenly stop the car, or it could be that there's lots of traffic in front of you and so you need to slow down in response to the vehicles that are slowing down in front of you. And how are you going to bring your car to rest? How are you going to bring it to a stop? Well, you're going to press the brake pedal. And so when you press that brake pedal, the brake pads, they clamp onto the wheels, and then friction then causes the wheels to stop turning, okay? And how long it takes the vehicle to stop and how far the vehicle travels while you're stopping will depend on a number of factors, and that's what I'm going to teach you about today. So we're going to break this down into 2 steps. You've got your thinking distance. This is how long it takes you to go from knowing that you need to stop to then getting that foot on the brake pedal. So at this point, you've not pressed the pedal. You're now thinking about pressing the pedal, and it's the distance that the car travels while the driver is reacting. So that is the standard definition. You could write that on a revision card. And this will all depend on a number of factors. So it can depend on your caffeine levels. It can be affected by your level of alertness. Are you tired? Because obviously if you are tired, that's going to slow down your reaction times. If you've been drinking a lot of caffeine and you are quite alert, that actually could be really good. That could reduce your reaction times. If you've been drinking alcohol or taking drugs, obviously that's illegal, then that can affect your reaction time. It can increase your reaction time, and that is not a good thing. Now, just to say, in the category of drugs, you can actually obviously describe that taking medicine is a drug, and some medicines can make you drowsy. So some people during the summer, they take antihistamines for their hay fever. Well, some antihistamines are classified as drowsy and non-drowsy. And if you read the side of the instructions, it will say about not driving and not using sort of heavy machinery, etc., while taking them. So some medications will make you drowsy. Could be that you've got a sore back and you've got sort of a painkiller for your back, and again that could make you less alert. And then the last thing, that last picture, I'm going to say this word, distraction. Okay, distraction, distraction, distraction. It could be that you're on your phone. Obviously, that's illegal whilst you're driving. It could be that you're eating some food because you're on the go, and so you're eating some food or having a drink. Some people do their makeup while they're in the car while driving. It might be that there's a screaming child in the back of your car, or you're kind of reaching your hand back to get something from the back seat, but we have to call that distraction. Now you can say distraction, e.g. mobile phone, that's fine, but make sure you've got this idea that it's the word distraction. Okay. And just to say, before we move on actually, that your typical reaction time is within 0.2 seconds to about 0.9 seconds. So it's less than a second, but it will be affected by a number of factors. Then, now let's imagine that you've put your foot on the brake pedal, you've applied the brakes, and now this is the distance that the car travels while the car is being stopped by the brakes. And again, this is affected by a number of factors, so we'll just talk through them. So you've got the road condition, and the condition word is quite important. Obviously, you can see from the pictures lots of potholes, there's kind of like lots of loose tarmac. So that could increase your braking distance. And it's not just the road condition, it's the actual road surface as well. Nice smooth tarmac will be very different to stop on compared to, say, loose gravel. And then also we've got the weather conditions. So the word condition is coming back again. Obviously then, if the road is icy or slippery or wet because it's been raining a lot, then that will make it far harder to stop the car. So that can affect the braking distance. The condition of your brakes themselves. So if your brake pads have worn out and they're quite tired and then they're not as new as they were obviously at the beginning, then worn out brake pads or worn out brakes can reduce your ability to stop. So they can increase your braking distance, and that's not a good thing. It could also be the tyres themselves. So tyres, there's a legal limit for the tread pattern on your tyres. And one of the ways you can test it is you can get a 20p coin. And around a 20p coin, there's kind of like a band around the edge. And if you put the 20p coin, if you put the 20p coin in the groove and you can't see that edge, then you've got enough tread. But if you put the coin in your tread and you can see that banding pattern around the edge, then your tyre is probably illegal and it needs changing for some new tyres. The other thing to say that's not sort of on here is the mass of the vehicle. So if you imagine someone's on their way on a lovely holiday, wouldn't that be nice? And they're going to the airport and they've got all the family in the car and they've got all of their luggage. That car is heavier than it would be normally, okay? And that means then it's got a higher mass, and a vehicle with a higher mass will also be harder to stop, okay? It's going to take a lot more force to stop that car. So that can affect it too. So we've done thinking distance, we've done braking distance, and if you add the two together, you get stopping distance. So stopping distance is the sum, it's the total, and you add your thinking distance, which is all about your reaction times, to your braking distance, which was all about once you've pressed the brake pedal, what is the road like, what's the weather like, what are your tyres and your brake pads like, how heavily loaded is the car. You add all of that together and you can see that there's a trend. So think about this now. So down the side, we've got the speed that the vehicle is travelling at. And if you go at 20 miles per hour, then you get a stopping distance of 12 metres. 6 plus 6, 6 is the thinking, 6 is the braking. Add them together, you get a stopping distance of 12. But if you have a car going at 70 miles per hour, it has a thinking distance of 21, but a stopping distance of 75, and you get a braking distance of 75, and then you get a total stopping distance of 96 metres. Now, you just need to imagine pacing that out. If you took a long step, which is roughly a metre, if you've got a car travelling on the motorway, because that's the place that you're permitted to do 70 miles per hour, or on a dual carriageway, if you're travelling at 70 miles per hour, it's going to take, once you've pressed the pedal, the brake pedal, it's going to take 96 metres to stop the car. So Why, when you're in residential roads, is the speed limit set to 30 miles per hour? Because obviously you've got lots of people on the paths, you've got other cars in front of you. So even at 30 miles per hour, it will still take 23 meters to stop the car, to bring it to a halt, which is why it's really important that when you're driving, you observe the street limits or the speed limits. And you need to pay attention to the signs, because if someone was to run out in front of you, God forbid, then you can see the distances that it would take to stop your car. And like I said, this is all very relevant. This is going to be applicable for you when you're doing your theory tests and then doing your practical driving tests very, very soon. So what I want you to do now is I want you to do some explaining. So I've put in the table all of the factors that can affect your thinking distance. They're the ones we've talked about, and then the ones that affect your braking distance. And what you need to do is pick one from each column. So one from thinking distance and one from braking distance. And then for each of those, how will it affect the distance that it takes to stop and why? So will it reduce the distance or will it increase the distance, and why? So why is it that using your mobile phone whilst driving, how would that affect the thinking distance and why? Or if you chose the weather conditions, if the road was icy like it was the other day when it snowed, then how would that change the braking distance and therefore the stopping distance, and why? So that's what you need to do now. So pause the video. Okay, so your answer is going to depend on which one you chose. But if I just take one as an example, so using your mobile phone whilst drinking, the first thing I want to say is how will it affect the distance? So using your mobile phone will increase the thinking distance because, and this is the why, because you're distracted from observing the road by looking at the screen of your phone, which may mean that you don't see the hazards in front of you and you're not able to respond very quickly. And so also we need to link into reaction time. So it increases your thinking distance because it also increases your reaction time. It makes you slower. You're slower to react. Let's take one from the other column. So braking distance, let's do the weather conditions then. So the weather conditions, let's imagine you've got icy roads. Well, that means then that you're going to increase the braking distance. And why? Because the ice is really slippery and smooth, you'll have less friction. So it'll be harder for the tyres to grip the road because they're icy. There's less friction, so it's harder to stop the car. And so then you will increase your braking distance. So this is very practical, as you can see. And if you take a photo of this work and then send it to us, we should see one from the thinking distance column and one from the braking distance column. Okay, so how do you investigate reaction times? We're going to do two things now. I'm going to talk to you about the ruler drop practical, but also I'm going to put a link on Google Classroom for something called a sheep dash, and you can click on that link and then basically the sheep dash out in front of you and you have to click the button and tranquilize them to stop them, and it will tell you your reaction time. So you can do that after the video. But this is a standard practical, this ruler drop. So what you would do is you'd work with a partner. One person would drop the ruler and the other person would catch. And you're not allowed to tell the other person when you're going to drop the ruler. And the other thing to be aware of is that you have to do it with your dominant hand. So if you're right-handed, then you would catch with your right hand. And if you were left-handed, you would catch with your left hand. So you work with your partner, first of all, and you work out which is your dominant hand. And then you would then sit there if you're preparing to catch the ruler, and the zero of the ruler needs to be next to your thumb. So if you imagine on this picture there were numbers, then the zero needs to be next to your thumb, and your hand needs to be ready to catch that ruler. Then your partner drops the ruler without warning, and you catch it as quick as you can. And remember, a ruler is not a stopwatch. So it's not going to give you a time, but what it gives you is a catch distance. So for example, you might catch it in 6 centimeters. And then what we would do is we would give you a conversion table that would allow you to convert 6 centimeters, your catch distance, into a reaction time, which would often be in milliseconds because they're often less than a second. So remember, you work with a partner, you would write down what your dominant hand is, so whether you're right-handed or left-handed. You're going to have to catch the ruler without warning. You line the bottom of the ruler, the 0 end up with your hand, and then when your partner drops it, they do it without warning, you catch the ruler and you record your catch distance. We don't record a time because remember, a ruler doesn't give you a time, it's not a stopwatch. And then you repeat this, say 10 times, and then you swap over. So you become the person dropping the ruler and then your partner would catch it, okay? So here's just an example of a conversion table. So I know I said the example of 6. So go to the table then, 6 centimeters, that's the catch distance, and then convert that into a reaction time, and that would give you 0.111. Okay, so it's less than a second. Okay, so 0.111 is the reaction time. And you can see, if you go to say 27, you get a reaction time of 0.235. So the higher the catch distance, the higher the reaction time. Okay. Like I said, we can't do the ruler one with you at the moment, COVID, stupid COVID, but you can do the sheep dash one. So you can follow the link and you can go and do that one and see what your reaction times are like. And it'll depend on a number of things, remember. It'll depend on how much sleep you've had last night. I don't know if you drink coffee, but it'll depend on what you've eaten and what you've drank, and how alert you are, how rested you are, all of those different things. So what I want you to do now is write a plan. And when we say a plan, we mean a method. So a method for this investigation to measure reaction times. Now, this is going to take you about 9 minutes. What you need to do is write out step-by-step instructions. So I need to see, number 1, do this. Number 2, do that. Okay, it needs to be laid out in numbered steps. And I've got all the keywords here that you would need. Now, the only thing I didn't mention before is that what you would do is you do it in a nice quiet classroom or a nice quiet room first. And then what you would do is you'd add a distraction. So you could add a distraction like loud music, and you repeat the same practical, but this time you put on some really loud music and then you play it and you see whether your reaction time changes. Or you could do before with no caffeine, and then you could have a caffeinated drink, and then you could test your reaction times again and you could see if they change. So write out a numbered method of how to do this practical, and that should take you about 9 minutes. And obviously you can pause the video and you can come back when you've got it done. Okay, so this is just an example. So the key point is that it's laid out in numbered steps and it follows a logical order or a logical sequence. So number 1, first work with a partner. One will drop the ruler and the other will catch the ruler. Secondly, record your dominant hand and use this hand to catch the ruler. Third, hold the ruler so that the 0 is next to the thumb and forefinger. So if you said hold the ruler so that the 0 is next to the hand, that's fine. Drop the ruler without warning. So you've got to say that it's the concept that you're going to drop it without warning. Number 5, record the catch distance and then convert it to a reaction time using a conversion table. Repeat this process 10 times. So if you said at least 5 times, that would be fine, but it's got to be 5 or more. Now add a factor which would be predicted to affect reaction times. For example, loud music. So you could have said caffeine, you could have said well, those are the kind of main ones that you would do. And then you repeat steps 1 to 6 with loud music playing whilst the ruler is caught. So you do the whole process identically, and the only difference now is that you've got loud music playing in the background. Okay, so that is the method, and the reason we're getting you to practice this is that you could be given questions, sort of method questions in your exams where you have to write this process out. And so it's an easy way to get marks, really. But it's about getting it in that numbered sequence. And some of the key bits of information is about that ruler, being at 0 next to the hand, dropping it without warning, recording a catch distance, and then converting it, repeating it, and then testing it with a different factor. So like the loud music. So here we've then got a task. So 4 students tested their reaction times using a computer program. So you can go and do a similar thing with the sheep dash soon. When a green light appeared on the screen, the students had to press a key. Table 3 shows their results. So you had boy 1, boy 2, girl 1, girl 2, and they each did it 3 times, and then they've calculated a mean. So remember, when a green light appeared on the screen, the students had to press a key. So it's time then to answer the 4 questions. And I don't know if you can see the very end of the 4th one, but it says, suggest further evidence you could collect to support your conclusion. I think my recording timer might be over the top. So pause the video and then come back. Okay, so here we've got the answers then. So from that first question, what is meant by reaction time in this experiment? So it was the time it took from seeing the green light to pressing a key. Okay, so that is from the question, that information, the time it took from seeing the green light to pressing a key. Second question then was, give one reason for the anomalous result in test 2. So that one, 0.47, it doesn't match the others in that series of results. So the answer then, he could have been distracted. So he could have been distracted at that point. So somebody may have come into the room, or his phone might have beeped or something. He could have been distracted. Give one conclusion that could be made from the results. So we need to say that the boys have a shorter reaction time than girls. Sorry, girls, we need to practice. So, I mean, it's just in this set of data. Let's do a wider study. So what else can you say, or how else could you say that? You could say boys have a quicker reaction time than girls, or boys have a smaller reaction time than girls. Okay. The other thing you can say is that the more you do the experiment, the more your reaction time improves because you're practicing. So that's the second thing that you could have said, but you only needed to give one. And then suggest further evidence you could collect to support your conclusion. So you would collect more data, you'd use a larger sample size. So to give a conclusion that boys have a shorter reaction time than girls and only test 2 boys and 2 girls, well, that's not good enough, okay? We would need to have a larger sample size. And then they only did 3 repeats. And so back in that previous method, I talked about how you would take 10. So take more repeat readings per person. So they only did it 3 times per person. Well, you could do it 5 times or 10 times per person. Okay, so that's just a typical exam question, so it's a good one to practice. And now it's time to look at some data again. So this is about 3 options when you're driving a car: not using a mobile phone, because remember it's illegal; using a mobile phone with a hands-free kit. So you're driving along, both hands are on the steering wheel, but you're talking to somebody on the phone, but it's hands-free. So you have both hands on the steering wheel. And then the last option is if you use a handheld mobile phone. So you are illegally holding the phone up to your ear, or you're illegally texting whilst driving, okay? So only the first 2 options are legal, by the way. You are able to use hands-free kits. Many people use them, but obviously the best option is not using a mobile phone. So we need to explain why driving whilst using a handheld mobile phone, so the third option, is more dangerous than using a mobile phone with the hands-free kit. So really, we're looking at the second 2 lines in the data. Okay, so tell me why driving using a handheld mobile phone is more dangerous than using a mobile phone with a hands-free kit. Okay, and there are some keywords that you could use, so please refer to reaction time, talk about those handheld mobile phones, refer to the thinking distance, and at that point you could be using the numbers, and also then refer to the overall stopping distance. So 4-minute clock, pause the video, and then come back in 4 minutes. And here is what you needed to say. So for our first mark, we're looking to say that the reaction time is increased by using a mobile phone for 1 mark. So the reaction time is increased. Now that doesn't come from the data yet, so let's start to think about the data. Handheld mobile phones increase the thinking distance. So you've got the trend by saying increase by more than 4 meters, because 23 meters and 27 meters, well, they're 4 meters apart. So using a handheld mobile phone increases the thinking distance by more than 4 meters compared to the mobile phone with a hands-free kit. So you get 2 marks for that bit if you said the 4 meters. If you just said that one increases the thinking distance more than the other one, but you didn't use any numbers, then you just get 1 mark for that point. And then your overall stopping distance will increase for a final mark. So that's why it's out of 4. Okay, so some quick exam questions then, and then we're finished. So the image below shows a lorry. The brakes of the lorry are in a poor condition. What effect will that have? What effect will the condition of the brakes have on your thinking distance and the braking distance of the lorry? So it's 1 mark each. Tell me what will happen to the thinking distance. Will it decrease, stay the same, or increase? Okay, so I hope you've paused the video. So this is 2 marks. So for each one, will they increase, will they decrease, will they stay the same? And this is what we should have. So our thinking distance stays the same. The condition of the brakes will not have any impact on your thinking distance, on your reaction times. But the braking distance, because of the poor conditions of the brakes, will actually increase. So that's how you get your 2 marks there. And then here is your last question then. So the stopping distance of a car depends on the thinking distance and the braking distance. Thinking distance depends on the driver's reaction time. Give 2 factors that can affect your reaction time. So there's lots of things you can say for that one, but just give me 2. Or actually, if you want to apply some good exam technique, maybe suggest a 3rd just in case. And then give 1 factor that can affect the braking distance. And you could cheat and you could use the one from the previous question if you liked. So 3 marks. Technically, you'd have 3 minutes in your exam for that one. Pause the video, come back. So here are the answers then. So what can affect your reaction time? You have any 2 from all of these. So it could be alcohol, drugs, it could be a named drug. You could say cannabis or ecstasy. Or it could be a named medicine, by the way, so it could be an antihistamine. Tiredness, distraction, and then a named distraction, so you can see about mobile phones or eating whilst driving. The age of the person as well. Older people have slower reaction times. And then if you just wrote drinking, but you didn't say what the person was drinking, then you do not get a mark, because they could be drinking water. Well, that's not going to affect their reaction time like drinking alcohol. So it's really important that you're being really clear. If you did say drinking, you would say drinking alcohol. So please make sure you're doing that. Or drinking coffee, because coffee is a liquid that contains caffeine, and it's the caffeine then that will affect your reaction time. Give 1 factor that can affect the braking distance. So it's any of these. So it's speed of the vehicle, condition of the tyres, condition of the brakes, condition of the road. That's why I'm trying to emphasize the word condition. It could be the weather. So if you didn't say water, ice or snow, but you said the weather conditions, that's fine. The braking force or the mass of the vehicle. So in terms of the braking force, just to explain at that point, if you had to do an emergency stop, so you're driving along, you're going quite fast and you have to slam the brakes on as hard as you can to make your car stop as quickly as you can, that's what we call a large deceleration. And the issue with large decelerations is that, first of all, you get a lot of friction between the brake pads and the tyres. And then the really bad thing that can happen is that you can lose control of your car, so it can start to skid. And then actually that's where cars can start to roll. So braking force, a really high braking force, can actually stop you from stopping. So having to suddenly slam on the brakes, which will be a really high braking force, that can then cause your car to skid and carry on moving because you're skidding, the wheel's not turning. So that's one of the reasons they can affect braking distance. So we're all done now. So that's your physics topic sorted. Remember, go and follow the Sheep Dash link so you can test your own reaction times and see how you're going. And obviously you're pre-lunch now at the moment, so you could test your reaction time before lunch, go and have some lunch, and then test them afterwards and see how they change. Okay, thank you. I'll see you next week.